All right, here we are today to talk about section 4.4, linear functions. Our essential question is, how can I represent linear functions using tables and graphs? So let's go ahead and define a couple of things. The first thing I want to define is the idea of a linear function. A linear function is just an equation in which the graph of the solutions forms a straight line. All right, that's something that we should have known thus far. Linear function has a constant rate of change or has a straight line when graphed. The only thing is, I'm gonna put in parentheses here, it cannot be vertical. That line cannot be straight up vertical up and down. And if it is, then that's going to show that an input has more than one output, and we've learned that that is not a function. The other part is we're going to look at today is something called continuous and discrete. And these ideas get a little bit confusing. I'm not going to lie to you. Continuous, this idea is where is data where the domain value can take on any form. And what that means is it can be a decimal. And this is, when we have this information, it's a straight line on the graph. All right? The other part is, that's a little bit different, is the idea of discrete. This is data where the domain value cannot take on any form. So it must be an integer. And for this, we don't have a line. We just have our dots or our points representing the information. Okay? So I'll kind of explain what that means here in our first example. All right? So it's just a word problem. Let's say it costs let's say, oh yeah, let's go $15 per ticket at AMC theaters to see movies. Let's think about it in the past, I guess. I don't know if AMC is open right now. Maybe it is, I don't know. Let's say it's cost $15 ticket to see movies there. All right, so we're going to represent this information with a table and graph. So the first thing that I would do is I would write this information as a function. This information as a function would be $15 per ticket. We don't know how many tickets that's going to be, and that's going to equal y or f of x. All that's saying the same thing. Then I'm going to take this information and I'm going to put it into an input-output table. Now, I normally tell you, all right, you need to have a pattern with your input when you plug in numbers here, and then you have to have a negative. Well, we don't want to put a negative here because you can't have negative tickets at the theater. So we'll just start at 0. 0, 1, 2, 3. All right? So 0 tickets obviously is going to cost us $0. 1 ticket's going to cost us 15. 2 tickets, 15 times 2 is 30. 3 tickets, 15 times 3 is 45. All right? So we're going to take this information and let's graph it. So I'm just going to create my own little graph here. I really only need quadrant 1. That's where this information's all at. All right, so let's go, let's go, each one of these lines, let's just go by 10. So 10, 20, 30, 40. And let's just go over by ones. 1, 2, 3, 4. All right, so let's plot this information. 0 tickets, $0. 1 ticket, 15. 2 tickets, 30. 3 tickets was 45. Let's say that was up here. Okay, so hopefully you can see that that information is linear here. Now, do we draw a line or not? Well, I have to look at my definitions. Continuous or discrete can be a decimal. The input can be a decimal. The input is representing tickets. Can I get a decimal portion number of tickets? Can I buy 1.5 tickets to the theater? No, you can't. This is discrete. It can only be an integer. So we don't put a line. We just have our dots. It is discrete. Example 2. Jewel is selling turkey let's go turkey meat, just so you know, from the deli, for $7 a pound. All right, I can take this information, I can write it as a function. F of x equals 7x, $7 a pound. Let's make it an input-output table. Again, I'm buying turkey meat by pounds. I can't have negative pounds, so I'll just start at 0, 1, 2, and let's go 3 again. So 0 pounds cost me $0. 1 pound would cost me 7. 2 would cost me 14. 3 would cost me 21. Now the question is, when I graph this, what's my graph going to look like? So we'll do the same type of stuff that we did before. That's fine. We'll go by tens. Should we go by tens again? 10. Sure, let's go by tens. 10, 20. We'll go over here by 1, 2, 3. 1, 2, 3. All right. So over here, this would be dollars. This is LBs for pounds. I guess we should put that up here. Tickets. Dollars. So 0 pounds is $0. 1 pound is about 7. 2 is about 14. 3 is about 21. It is linear. You can see that straight line for our makeshift graph. Can I get can my inputs be decimals? Can I buy a half a pound of turkey or 2.3 pounds of turkey? That information is yes, I can. This is continuous. So you're just gonna have to ask yourself that. And since it's continuous, I put the line in. Continuous and discrete, sometimes tough just because it's kind of worldly information that you just may have not experienced yet. All right, that's all I got. If you got any questions, let me know.